So welcome back to the second part of our two-part series on inverses. So today what we'll do is we will look at computing inverses using Gaussian elimination. So before doing so, let me review the concept of an inverse. So A was a square matrix. So it's an n by n matrix. And we say it's invertible if whenever I multiply it on the left and on the right by a certain square matrix too, I get the identity back again. So I want to C such that AC is the identity and C times A is the identity. And when this happens, that means that A is invertible, and it's also, the inverse is also unique. So I can write C as being A inverse. Okay, so this is if A is invertible. Okay. So for example, in the 2x2 case, we saw if A was equal to A, B, C, and D, A is invertible if and only if AD minus BC is not equal to 0. Okay, so that gave us the condition on invertibility. And once I have the condition on invertibility, I can write an explicit formula for the inverse. So A inverse is equal to 1 over AD minus BC. And what do? We take the diagonal entries and we switch them around, and we negate the entries on the off diagonal parts. Okay, good. And we did examples of 2x2 cases last time. So let me give you the example we did in the last class. So the explicit example we did was when A was the matrix C minus 7 or 3 minus 7 minus 6 and 13. We just apply our formula, and the inverse was given as follows: minus 1/3, and we have 13, 7, 6, and 3. Okay, great. All right, now that sort of begs the question, well, what happens in the n by n case? So I want to look at the n by n case next. And so let's analyze that and see, what we can do in the n by n case. So in the n by n case, I have A times A inverse, and that's the identity matrix. So for the moment, let's say that x1 up to xn, this is the identity matrix. This is the inverse of A. And so let's just label the columns by x1 up to xn. Okay. Now, when I write this out and I apply A, this is the same as taking A on x1, A on x2, and A on xn. And remember, we're assuming that this is the identity matrix, like this, with ones down the diagonal. And so what are we really doing to find the inverse? Well, we have to solve a certain system of equations. So this is equivalent to solving the following system. A times x1 is equal to the unit vector 1, 0, 0, 0. A times x2 is the next unit vector 0, 1, 0, 0, 0. And then finally, AXN is equal to the last unit vector 0, 0, 0, 0, 1. Okay, so what we can do to solve the inverse is to solve this n system of equations. Okay, so one can solve like n systems of equations. Now that's all fine and dandy, but what we can try to do instead is we can try to do this all simultaneously. And the way to do it simultaneously is instead of writing A and then put a line down there, B, what we can do is we can put the entire identity matrix down. Okay, so I have A on the left-hand side, and I have the identity matrix on the right-hand side. And then I could perform Gaussian elimination like before. And then the idea is to get the identity matrix on the left-hand side after Gaussian elimination, and the right-hand side will give us, so this is using Gaussian elimination. So on the left-hand side, we'll get the identity matrix. And on the right-hand side, we want to have the identity. Sorry, on the right-hand side, we want the identity matrix. On the left-hand side, we get the inverse of the matrix. So we transform using row operations. And once we can get the identity matrix on the right, then out will pop A inverse. Okay, so that's the procedure. All right. Now, just to make sure that I'm not pulling a fast one on you, I think we should try this on the example that we've done before. So let's do that. So let's go back to the example and apply the procedure. All right. So remember what A was. A was 3 minus 7 and minus 6 and 13. Okay. All right. So what are we going to do? We're going to start with A and the identity matrix and then do row operations. All right. So let's put everything in. So 3 minus 7 minus 6 and 13. Put a line, and then you have the identity matrix on the right-hand side. Okay. So we're going to perform row operations. So I have to knock out the minus 6. So I'm going to use 3 as a pivot. So I'm going to multiply the first row by 2, add it to the second row, put it in the second row. Okay, so let's do that. Keep the first row the same. Okay, so 3 minus 7, 1, 0. I get a 0 here. And what do I get? I get a minus 1. And then I go all the way across. It's 2 plus 0. And so that's going to be a 2. And then 2 times 0 is 0 plus 1. And that'll be just a 1. Okay, so I'll just sit for a second. So you should think about why this works. Okay, great. Now the thing is, I want to eliminate the minus 7 next, because remember, I want the identity matrix to be on the left-hand side. Okay, so basically, I want to use this thing as a pivot, and then I want to go up. So I'll multiply the second row by 7. So let me write this step down. So 7 times row 2 plus row 1, and I'm going to insert this into row 1. Okay, so that's the procedure I'm going to do next to knock out the minus 7. All right, so let's do that. Okay, so we keep the second row the same, 0, -1, 2, 1. And let's do this. You almost have to think about like standing on your head to do this, right? You kind of have to do it the other way than what we've done it before. Okay, so here we go. All right, so the first thing is 7 times 0 plus 3, that's 3 still. Okay, so -7 plus 7. Actually, I should do a, let's see, I guess I should put a -7 in here. Okay, so I should put a -7 in here just to do that correctly. Okay, so it's -7 times the first one. Okay, good. So then I get a 0. Okay. Okay, so -7 times 2 plus 1, that's -13. Okay. Just make sure we do this right. And then we have a -7 up at the top. Okay. All right. So everybody good with that? All right. So the next thing we need to do is we need to transform this into the identity matrix. So what we have to do is we have to multiply both sides by 1/3, each row by 1/3. Okay, so the top row by 1/3 and the bottom row by -1. Okay, so let's do that. Okay, so I take 1/3 of the top row, and what do we get? We get 1, 0, -13 over 3, and 7 over 3. Okay, and then multiply the bottom row by -1. I get 0, 1, -2, -1. Okay, and so now I have the identity matrix on the left-hand side, and the inverse is on the right-hand side. So A inverse is equal to -13 over 3, 7 over 3, -2, -1. Now, is that going to be the answer that we had beforehand? Well, the answer involved, dividing by 1 over the determinant AD minus BC, right? So I have to pull out a -1/3 and see if the answers match up. So let's pull out a -1/3 here and see if the answers do match up. So what do I get? I get a -13. Let's see, is this correct? Yeah, I should get over 13 here. So somehow I have a minus sign. Let me just check my work here. So this is -13 over 3. So that should be a 13. Oh, divide by that. That's right. So this should be a 13. Okay, just make sure. Everything good. Okay. So then I should get a, let's see, oh, I see my mistake. So there should be a minus here, minus, minus, right? So there should be a minus here. Okay, so that's good. So here's a 7, all right? And then I should have a 6 and a 3. Okay, so let's check the answer with the top here. And that turns out to be the right answer. Okay. All right, so it does match up with the answer that we had before. Okay, so you have this answer here, and then up here you have this answer up here too. Okay, so they do indeed match up. Okay, so now let's do another example. And this will be an example where we look at a 3x3 matrix and we apply the same procedure. So here A is going to be the matrix 1, 4, -3, and -2, -7, and a 6, and 1 and a 7 and a -2 here. Okay, so it's a 3 by 3 matrix. And so we're going to apply the same procedure, but it's going to be a little bit more complicated. Okay, so let's do that. So remember on the left-hand side, we're going to put A, 1, 4, -3, -2, -7, 6, 1, 7, -2. On the right-hand side, we're going to put the identity matrix. Okay, so the idea is to transform the left-hand side to the identity, and then on the right-hand side, I'll get the inverse. Okay. So first of all, you just have to be careful and methodical about doing this. So I'm going to use the 1 as a pivot. I get 1, 4, -3. Make sure we don't drop minus signs. Okay, so what do we get? We get a 0 here. Then we get a -1. Is it right? No, it's a 1. Sorry. And then we get 6 -6, and that's going to be a 0. Okay, the next one is going to be a 2. The next one's going to be a 1, and it's going to be a 0. Okay. And now I can knock out the 1 down here by multiplying by -3. Okay, so -3 times the first row plus the third row, and then insert it into the third row. Actually, it shouldn't be -3. What am I thinking? Just to show you that my presentations aren't completely canned. It's not like Khan Academy here, so okay. So we can make a few mistakes. All right. So let's take -1 times the first row and add it to the third row, and then put it in the third row. Okay. So here we go. We got 0. 7 -4 is a 3. -2 plus 3 is a 1. Okay. And then I get a -1. I get a 0, and I get a 1 here. Okay, let me stop. Make sure everybody is with me. Okay, good. All right, so the next thing is to get rid of the 3 down here. So I'm going to multiply the second row by -3 and use that 1 as a pivot. So 1, 4, -3, 1, 0, 0, 0, 1, 0, 2, 1, 0 still. And then I get 0, 0, 1. That's good news. And then -6 plus -1 is -7. And we get a -3 here. And then we get a 1. Okay. So the nice thing is we have 1s down the diagonal, so we're probably not going to have to divide at the end. All right, good. So the next thing we're going to do is we're going to use this 1 here, and we're going to knock out the first row, the -3 in the third row. So we're basically going to take row 3. Actually, we're going to take 3 times row 3 plus row 1, and then we're going to insert this into row 1. Okay, so that's really what we want to do. So let me try to move it over slightly so that we can see how to do that. Okay, so the first 2 things stay the same. So let's just write this down. And then 0, 1, 0, 2, 1, 0. Okay, so multiply by 3 here. Okay, and then add it to row 1. All right, so what do we get? We get a 1 here. We get a 4 still. And then we knock this out and we get a 0. And then we get -21 plus 1. That's going to be -20. And then we get a -9. Okay, and we get a 3. Okay, let's make sure that's correct. All right, so I mean, the numbers can get, fairly complicated. They can get big and they can get complicated, but it's amazing that this procedure will actually work. All right, so we're almost done. We just have to get rid of the 4, and we need to do this by using the 1 as a pivot and then knocking it out. So we're going to multiply the second row by -4, and we're going to add it to the first row and then replace the first row. Okay, so again, we keep rows 2 and rows 3 the same. Okay, so row 3 stays the same. And then row 2 is the same. Okay, and so all we're going to do is we're going to change row 1 now. Okay, so now let's do this. So this is going to be a 1. We're going to have a 0 here. And we're going to have a 0. Yay, we have the identity matrix. Okay, and now let's do the last part. So we have -4 times 2, that's -8, plus -20, that's -28. Okay, and then we have -4 -9, that's -13. Okay, and finally 0 plus 3, and that's going to be a 3. Okay, so we've transformed this part into the identity matrix here, and this part will be A inverse. Okay, so I'll just write A inverse out, the answer. And you could actually go back and take the matrix multiply and show that it is the identity just to check things out. I won't do that here, but you can do that. And then let's just write it out very nicely here. Okay, make sure we didn't make any sign errors or anything. Okay, good. Okay, so the answer is A inverse is equal to this. Okay, great. So this concludes this presentation on inverses, the second part. And so I will actually continue on with another video later on in terms of looking at the implications of this algorithm in terms of the theory that we've learned so far. Okay, again, thank you for your attention.